everyone, sorry I can't be there in class today. I just want to do a quick video on a review of factoring, especially the factoring completely aspect, because that's the part I think that's the hardest. And you can also have this accessible to you anytime you need to go back and look at any of this stuff. So just a reminder that there's 3 different ways that you can factor. You can either factor by GCF, by a difference of perfect squares, and by unboxing or undoing the foil. So just a reminder, for GCF, there's always something in common with all the terms in the expression, and you can have as many terms as you want in a GCF. But with a difference of perfect squares, it has to be a binomial. It has to have 2 terms. It has to have subtraction. It has to have perfect squares. And then lastly, with a unbox or unfoil, it has to be a trinomial. And it works when you try to work backwards from foil or the box. So let's take a look at each one of our examples that we have here. So in our first one that we have here, this GCF question, 8x squared plus 20x. So first thing I need to do is identify what my GCF is. So what's the largest number I can divide 8 and 20 by? And that number is 4. But just a reminder that you can actually go into Desmos and figure it out using Desmos if you're not sure. So just a reminder that you can type in GCF, open up your brackets right here, and then you can write 8, 20, and here our answer would be 4. So our GCF right here would be 4, but there's also x's in common right here, and we look for the lowest exponent, so it's x to the power of 1. So this is 4x. And just a reminder that when you're factoring by GCF, you're undistributing, and when you distribute, you're multiplying. So when you undistribute, you want to divide. Okay, so when I divide right here, 8 divided by 4 is 2, and then x squared divided by x. When I divide, I subtract my exponent, so I end up getting x to the power of 1, or just x. Here, when I divide 20x by 4x, 20 divided by 4 is 5, and then the x's cancel, so this is my answer right here. Just a reminder that if you were to distribute this through, you would get this answer right here, so you'll know if you did it right or not. So I just want you to make sure you're understanding that when we factor by GCF, we're trying to undistribute, because you're all really good at distributing. And if we remember that, that will help us with our factoring by GCF, okay? Okay, so now for difference of perfect squares, in this example right here, it is a binomial because there's 2 terms. There is subtraction, and both of these are square rootable. So when I factor this expression right here, the square root of x squared is x, the square root of 100 is 10, and then we put a plus and a minus. It does not matter what order you go in, and that's your answer right here. All right, lastly, if I want to unfoil or undo the box, it has to be a trinomial. So we have to have 3 terms, 1, 2, 3 terms right here, which we do. And I'm going to do the box right here. So I know that I have to have x squared. I have to have negative 7x and then negative 18 right here. X times x is nice because those are the only things that multiply together to give us x squared. But for 18, let's make our list. So I can do 1 and 18. I'm just literally going to go in order 1, 2, 3, 4 until I get all the possible options. 2 works because 2 times 9 is 18. 3 works because 3 times 6 is 18. 4 doesn't work. When I divide 18 by 4, I get a decimal. And 5 doesn't work. 6 works, but it's already in our chart, so we're done. So now I'm trying to get this negative 7x from these factors right here, and the only numbers that will work are 2 and 9. So if I put a 2 here and a 9 here, watch what happens. I get 2x here, I get 9x here, and if this 9x was negative, negative 9 plus 2 is negative 7. So I know that that works. So that means that when I factor this, I would get x minus 9 times x plus 2. And just a reminder, you can also say x plus 2 times x minus 9, as long as the 9 is negative and the 2 is positive. All right, cool. So when we factor completely, we're going to ask ourselves these questions in this order. So first question, is there a GCF? Then, is it a difference of perfect squares? What's left over, if there's anything left over, is what's inside the brackets a difference of perfect squares? And then lastly, can I unfoil or undo the box? So in our first example right here, 7x squared minus 7, first thing I ask is there GCF? And yes, there is. There's a 7 in common. They're both divisible by 7. So when I factor a 7 out, 7x squared divided by 7 So I'm going to divide these two terms here, gives me x squared. And then negative 7 divided by 7 gives me negative 1. So I factored out my GCF. Then I take a look at what I have inside of here. I completely ignore the 7 and I ask myself, what do I know about this expression inside of here? Well, it's a binomial, it's subtraction, and there's two terms. So when I do this right here, I would end up getting a difference of perfect squares. So the square root of x squared is x, the square root of 1 is 1, and then I have a minus and a plus, and then I just copy the 7 down in front. So this is what I get when I factor this completely. Cool. So in number 2, first thing I'm going to ask myself is there a GCF? And yes, there is a GCF. They're all divisible by 5. So when I factor out a 5 right here, I know I can divide all of these terms by 5. But just a reminder, if this is negative, I want to factor out a negative 5. So when I do that, negative 5x squared divided by negative 5 is positive x squared. Positive 65x divided by negative 5 is negative 13x, and then negative 200 divided by negative 5 is going to give me a positive 40. Then I look at what I have inside of here, and I see if I can factor this any further. It's not a difference of perfect squares because there's 3 terms, but I'm going to try to see, can I unfoil this or can I undo the box? So let's go ahead and try. So I know that this is x squared, I know this is negative 13x, and I know this is 40. I know also that this has to be x and x because those are the only things that multiply together to give me x squared. Let's make our chart for 40. So I know I can start with 1. 1 and 40 will work. 2 will work because it's an even number, so 2 times 20. I can't divide 40 by 3. I can divide it by 4 and I get 10. I can divide it by 5 and I get 8. I cannot divide it by 6 or 7. I can divide it by 8, but 8 is already in this chart right here. Now I'm looking for which set of numbers can possibly give me this negative 13 that we have in the middle of our box right here. And so I can't get it from 1 and 40 or 2 and 20 or 4 and 10. There's no way I can get the number 13 from those numbers here, but 5 and 8 can give me a negative 13. So this would be 8x, this would be 5x. It gives me a negative 13 if this is negative and if this is negative right here, which means the 5 is negative and the 8 is negative. So this factors out to x minus 5 times x minus 8, or if you do it the other way around, totally fine. And then we just copy down this negative 5 and this is completely factored. Okay, people, in our next example, we have a little bit of a typo right here, and this should say minus 2x. So this should be negative x squared minus 2x plus 80. Just like we always do, the first thing we want to do is see if there's a GCF, if there's anything in common right here. And although there's nothing in common with these 3 terms, we just don't like this negative right here. So we're going to factor that negative out. So we could say negative 1, or we could just say negative. It's the exact same idea. Now, when I factor it out of negative x squared, it becomes a positive x squared. When I factor it out of negative 2x, it becomes a positive 2x. And when I factor it out of 80, it becomes a negative 80. And just a reminder, if I were to distribute this negative through, this right here is what I would have gotten. Okay, so now let's go ahead and see what I can do with what's inside of my brackets right here. So in these brackets right here, I have, it's not a difference of perfect squares because it's 3 terms. So I'm going to try to see if I can undo the box. So I'm going to put x squared, 2x, and negative 80. Okay, and then we know again that this is just going to be x times x. I'm going to make my chart for 80 right here. So I know 1 will work because 1 and 80, when I multiply them together, gives me 80. 2 times 40 gives me 80. I can't divide 80 by 3, so 3 won't work. When I divide 80 by 4, I get 20. When I divide 80 by 5, I get 16. I cannot divide 80 by 6. I cannot divide 80 by 7, but 80 divided by 8 is 10. I can't divide 80 by 9, so then this is as far as I can go because 10 is already on my list right here. So which set of numbers can I possibly get a 2 from? Not 1 and 80, not 2 and 40, not 4 and 20, not 5 and 16. I can get a 2 from a 10 and an 8. So let's see here. If I have 10x here and 8x here, if I have a positive 10 and a negative 8, that gives me a positive 2. So that means this 8 right here is negative. So I just will write down right here x plus 10 times x minus 8, or the other way around, and then just bring this negative down in front, and I'm all set to go with this question right here. So now I want to solve this equation right here, and because there's an x squared here, the only way I can solve this equation is by factoring. I want to see, I need things that multiply together to give me 0, because just a reminder, if I have a times b equals 0, then either a is 0 or b is 0. One of these two things has to be 0. So that's why we factor it to get two different factors. So first thing I'm going to ask myself is there a GCF? Is there anything in common with these three terms? And yes, there is. My GCF is 18. So when I factor out 18 from 18x squared, I get x squared. When I factor it out from negative 36x, I get negative 2x. And when I factor it out from negative 54, I get negative 3. Don't forget to copy down that equals 0. Then I'm going to look inside of this right here and see, do I have any factoring that can get done right here? And absolutely I do. I'm going to try to undo the box for this one right here. So this, I'm going to put x squared inside of my box right here, negative 2x and negative 3. So x times x is my only set of options. The nice thing about 3 is only 3 and 1 will work. So this is 3x, this is 1x, but I can get a negative 2x if the 3 is negative and the 1 is positive. Also, negative 3 times 1 gives me this negative 3 in the corner right here. So that means I end up getting x minus 3 times x plus 1. And don't forget to copy down this 18. Now I have three things that are multiplied together to give me 0. Here's one of my factors, here's another one of my factors, and here's my third factor. So I can go through and set each factor equal to 0. So my first factor is 18, and because 18 is just a number, it will never equal 0, so I don't have to worry about that. X minus 3, I would set equal to 0. In order to solve this, I would add 3 to both sides, so x equals 3. And then here, x plus 1 equals 0. Subtract the 1, and I get x equals negative 1. So that means here that my two answers, my two solutions, are 3 and negative 1. In number 5, the first thing I ask myself is there a GCF? And although there's nothing really in common with these three terms, I want to factor out this negative because I just don't like it. So when I factor out that negative, I get x squared plus 2x minus 35, because I just changed the signs for all three of these terms right here. Dividing by a negative changes those signs. And then I'm going to go ahead and try to factor this right here. So I'm going to factor this the other way that we've done as well, because you don't always have to use the box. I know x times x right here is going to give me x squared. I'm going to look for two numbers that I can multiply together to give me 35. So 1 and 35 will work. 2 doesn't work. 3 doesn't work. 4 doesn't work. 5 works. 5 times 7 is 35. 6 doesn't work. But 7 works, but it's already in my chart, so I don't have to worry about any other numbers. And this I can get a 2 from right here. So I'll try a 5 here, a 7 here. So I know that my inner will give me 5x. I know my outer will give me 7x. These are the same things that we would have in our box. And 5x and 7x would give me 2x if the 5 was negative and if the 7 was positive. But then I need to copy that negative down in front right here. And if you notice, I still have three things multiplied together to give me 0. So what are those three things? I have this negative 1, I have this x minus 5, and I have this x plus 7. So right here, when I do this, set each part equal to 0. Negative 1 can never equal 0. X minus 5 equals 0, so x equals 5, add 5 to both sides. X plus 7 equals 0, subtract 7 from both sides, and I get x equals negative 7. So that means my solutions are 5 and negative 7. And I think that's it for this video. We don't have to do number 6 together because I feel like we've given you a lot of examples. If you have any questions, please feel free to email me and I would be more than happy to help you out. And I hope that you have a great day. Looking forward to seeing you tomorrow. And please make sure that you are kind to your sub. All right, I'll see you tomorrow. Bye, everyone.